Hello students, welcome to a new video. In today's video, we are going to derive the mirror equation. The mirror equation is 1 by v plus 1 by u is equal to 1 by f. Here v is the image distance, u is the object distance, and f, small f, is the focal length of the mirror. This formula is applicable for both the spherical mirrors, that is the concave mirror as well as the convex mirror. Now in the derivation of the mirror equation, we will consider a ray diagram like this. We have considered here only the concave mirror. For this concave mirror, we have considered, for it is convenient for us to consider three rays. The first ray is this one, a ray which is parallel to the principal axis. Secondly, a ray which is incident at the pole of the mirror, and the third ray which passes through the center of curvature of the mirror. Here we have considered AB to be the object, and we have considered three rays. First ray is this one, second ray is this one, and the third ray this one. We have considered three rays emanating from the object AB. Now see, for this ray which is traveling from A to M, for this ray is parallel to the principal axis, and after reflection from the mirror surface, this ray will always pass to the focus. As we have already come to know that a beam of rays or a ray which is parallel to the principal axis will always pass to the focus after reflection from the mirror. So this for this ray, after striking the mirror surface, it will always pass to the focus of the mirror. Here F is the focus of the mirror. We will consider a second ray which is passing to the center of curvature. Now for this ray which is passing to the center of curvature, see, at this point this ray will be normal to the mirror surface. Okay, so for a ray traveling normal to the mirror surface, what will happen after reflection? That ray will always retrace back its path. So this was the direction of the incident ray which is passing through the center of curvature of the mirror, and it will go and strike the mirror surface at the point N. After reflection from this point N on the mirror surface, it will retrace back its path. So we will get a reflected ray along the same direction in this way. Okay. Again, let us consider a third ray. We have considered here a third ray which is traveling towards the pole of the mirror. Now for this ray, this is incident at the pole of the mirror. Here P is the pole of the mirror. So this ray is incident at the pole of the mirror. What will happen? This ray will follow the laws of reflection. After following the laws of reflection, it will make a angle of reflection which is equal to the incident angle. Here this is the incident angle and this will be the angle of reflection. Okay, so this ray is making an angle of incidence at this point, right? So it will follow the laws of reflection and it will get reflected in this direction. So what we can see here is, after reflection from this mirror surface, this ray is passing through this point, the second ray is passing through this direction, passing along this direction actually, and the third ray which is passing to the center of curvature is coming back along the same direction. These are the three rays. Now see, these three rays are meeting at the same point. This is the same point. These three rays are meeting at the same point. So we are getting the image which is an inverted image at this point. Here A dash, B dash is the image for this object. Okay, so we have seen here the image formation for the object AB by this concave mirror. So here AB is the object, A dash, B dash is the image, object distance is taken to be U. What is object distance? It is the distance of the object from the pole of the mirror. This is taken to be the distance between the object and the pole of the mirror is taken to be U. And what is V? V is nothing but the distance of the image. Here image is formed here, so this is the distance of the image from the pole of the mirror. So this is taken to be V. And what is F? F is nothing but the focal length of the mirror, and its distance is measured from the pole of the mirror to the focus. Remember one thing, according to the sign convention, all distances are measured from the pole of the mirror. In this diagram, we consider the ray AM to be a paraxial ray. Now what is a paraxial ray? A paraxial ray is a ray which is parallel to the principal axis as well as it is very close to the principal axis. So for this case, if AM is a paraxial ray, then that ray will travel very close to the principal axis. Okay, so in that case, the point M will be very close to the point P. Why? Because that ray is traveling very close to the principal axis. Therefore, the point M will be very close to the point P. Now, if this point comes down, if it is considered somewhere here, then what will happen? The distance MP can be considered to be a straight line. Okay, the points MP, if we connect the points MP, then that line can be considered as a straight line for para-axial rays. So here I have written, for para-axial rays, MP can be considered to be a straight line. And how will be this line? This line will be perpendicular to the principal axis. Okay, so we can simply drop a normal at this point and consider this point to be the point P. Okay, so we have dropped a normal to the principal axis at this point, and we have considered this point to be point P for a para-axial ray. Now for para-axial rays, the MP can be considered to be a straight line which is perpendicular to CP. Now see, if we consider these two triangles, if this is a straight line, then this will become a triangle MFP. Okay, so this will be triangle MFP, or we can say MPF. This will be a triangle, and we can consider another triangle which is A', Now see, these two triangles are almost similar, so we can consider to be similar triangles. Why? Because this side corresponds to this side, right? This base corresponds to this base B', okay, and for the third side, this is the hypotenuse. The hypotenuse also corresponds to this side of the second triangle. So what we can consider? We can consider the first triangle A', and the second triangle MPF to be similar triangles. So for that case, we are going to write the similarity condition. Now how do we write the similarity condition? While writing the similarity condition, we just take the ratio of the corresponding sides for the two triangles. Okay. Now for we have written here triangle F is similar to triangle MPF. So for these two triangles, we must take the corresponding sides, the ratio of the corresponding sides of the two triangles. Now for these two triangles, the side A', B' of the first triangle, this side, the side A', B' of the first triangle corresponds to the side PM of the second triangle. Okay, so we have taken the ratio B', A' divided by PM. Now if we are going to write a similarity condition, then we have to take minimum two sides. Okay, so for that we are considering the second sides also. The side B', the side B' of the first triangle corresponds to which side of the second triangle? The side B' of the first triangle corresponds to the side FP of the second triangle. So we have just taken the ratio B', divided by FP. So this is the similarity condition for these two triangles. Here PM is nothing but the distance B'. Okay, this distance is equal to this distance, therefore PM can be considered to be BA. So I have written here BA instead of PM. So this is our first equation. Now from this diagram, we can easily say that this angle is equal to this angle. Why? Because this is the angle of incidence and this is the angle of reflection, and this ray follows the laws of reflection. Therefore the incident angle will also always be equal to the angle of reflection. Okay, so in this case, angle APB will be equal to the angle A', So I have written here angle APB is equal to angle A', So if these two angles are equal, then what will happen? Triangle A', this triangle A', and the second triangle APB', these two triangles will be similar. Okay, so if these two are similar triangles, then we can use the similarity condition, right? So for this, if we are going to put the similarity condition, then what we can write? The first side of the first triangle A', B', or we can say B', A'. That side corresponds to which side of the second triangle? That side corresponds to the side BA of the second triangle. Similarly, we have put an equal to sign here. We are using the similarity condition. So we have to consider minimum two sides of the triangles. Okay, in order to write the similarity condition. Therefore, for the second case, I have taken a side B', Now here B', is this side. This side of the first triangle corresponds to which side of the second triangle? The side B' of the first triangle corresponds to the side BP of the second triangle. Therefore, I have written the ratio B' divided by BP. This is our second equation. So this was our first equation and this was our second equation. Now see, if we compare these two equations, then we can see that the left hand side of the two equations are the same. Therefore, we can equate the right hand sides of these two equations. So if we equate the right hand sides of these two equations, then we will have b dash f, this term b dash f divided by fp, that will be equal to this term, that is b dash p divided by bp. Now here, what is b dash f? B dash f is this distance from here to here, and this distance is nothing but b dash p minus fp. So b dash p minus fp. If we neglect the distance fp from the distance b dash p, then we will obtain the distance b dash f. So I have written here, in place of b dash f, b dash p minus fp. Okay. In the denominator we have fp, and on the right hand side we will, the term remains the same, that is b dash p divided by bp. This is our third equation. Now at this point we will have to use the sign convention. According to the sign convention, what is b dash p? We'll have to substitute these values. Okay. Now what is b dash p? B dash p is from here to here, this distance. Okay. Now see, according to the sign convention, all the distances are measured from the pole of the mirror. If the distances are measured from the pole of the mirror towards the right hand side, that is in the direction of the incident light, then those distances will be considered to be positive. Okay. Now in this case, the incident ray is moving in this direction, and if I am measuring the distance of the image, then we'll have to move backwards from the pole. So we are moving in the opposite direction of the incident ray direction. So the incident ray is moving in this direction, and we are measuring the distance backwards. So in this case, this distance will become negative. And what is this distance? B dash p. B dash p is nothing, it is v. Okay, image distance. And since we are moving in the backward direction, in order to measure the distance, therefore we have to put a negative sign here. This is b dash p. Now what is fp? What is fp? F is this point and P is this point. So this is nothing but the focal length. The focal length can be written as small f, right? Now see, all the distances are measured from the pole of the mirror. The incident ray is going in this direction, we are measuring the distance in the opposite direction. So for this case also, there will be a negative sign in front of the small f. What is the other term? BP. So BP is from this point to this point. Okay, we are measuring the distance in the opposite direction. We are measuring from the pole to the to this point. So this is the object. That means the distance BP is nothing but the object distance. So this will be u. But since we are measuring in the opposite direction, therefore we have to put a negative sign here. Now if we substitute these values in this equation, then what will happen? B dash p will become minus v minus, what is fp? Fp is minus f divided by fp, this is minus f, is equal to b dash p. B dash p is minus v divided by bp. Bp is minus u. Okay. So this is our main equation. Now if we simply solve this equation, then we are going to obtain the mirror equation. Now let us simply solve this mathematical equation. Here minus v, minus of minus f, here we can take plus instead of minus into minus. So minus v, this becomes minus v plus f divided by minus f is equal to, if we cancel the negative signs, then it will become v by u. Now here what we have done, we have taken the negative sign to be common. Okay, we have taken out the negative sign, so negative and negative gets cancelled out. We have v minus f divided by small f, that is equal to v by u. Here what we have done, we have just cross multiplied. Okay, so if we cross multiply this with this and this with this, then this becomes u into v minus f is equal to vf. Here v minus f remains. What we have done is we have taken u to the other side and v to this side. Here also we have just cross multiplied. So if we cross multiply, then this becomes v minus f divided by v is equal to f by u. Okay, now bring that f to this side. We have to brought this f to this side. We have cross multiplied, and if you cross multiply, we have v minus f divided by vf, that is equal to 1 by u. Okay, divide this term by vf. If we divide this term, then we have to divide both the terms of the numerator by vf. So this becomes v divided by vf minus f divided by vf, that is equal to 1 by u. If we cancel out these terms, then what we will get? We will get 1 by f minus 1 by v is equal to 1 by u. Okay, and this is nothing but 1 by v plus 1 by u equal to 1 by f, and this is what we call the mirror formula. This is the mirror equation. Okay, clear? Thank you.